All right, are you ready? We're now going to redo sections 1 through 3 in chapter 4, and this time we're going to look at radian graphs. Okay, don't freak out on me, I know you can do this. Let's start out by looking at y equals sine of theta and how the sinusoid looks different when we graph it in radians. Good news, amplitude is still 1, so the graph travels up to 1, down to -1. Also good news, we start at 0, 0. Here's where it changes. Instead of 360 degrees for the period, we're going to cancel that and we're going to say that the period is 2 pi. So what that means is that one cycle is 2 pi in length. All right, so this is going to be 2 pi. Still do the midpoints. You guys are good at midpoints. Halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2, and this is 3 pi over 2. Okay, so then we just simply put in the points that represent the nice smooth sinusoid curve. All right, not bad. Let's go ahead and do the cosine, and then we're ready to transform it. Okay, so y equals cosine again. Amplitude, we travel from -1 to 1 on the y-axis. 2 pi is the period. The points that we have to have on the x-axis coincide with their with what we used to do with degrees, but this time we start up, travel to the middle, minimum, middle. Here we go, and there's the cosine. All right, so let me just say that you will have to use a lot of fractions in this, and so you need to not be afraid of the fractions but embrace them. So here we go, we're just going to jump right into it, and we're going to graph y equals -4 plus 6 cosine, and we'll start out where we don't put a value in for the c. We're just going to keep this and not change the period. We're going to keep the period at 2 pi. All right, so what does all this mean? Just as it meant before, we have a new midline at y equals -4. We travel up 6 to 2 and down 6 to -10, right? This means we start pi to the right, so we're going to go ahead and do that. 2 pi is the period, so this cycle is going to end 2 pi later. And so I hope it makes sense to you that from pi, when we add 2 pi, we end up at 3 pi. Perfect. All right, so halfway between pi and 3 pi, add them together, divide by 2, we get 2 pi. Add them together, divide by 2, we get 3 pi over 2. 3 pi plus 2 pi, 5 pi over 2. All right, and then we simply play dot to dot, and we connect, and we have this nice, fabulous transformed sinusoid. See, it's not bad. I told you it wouldn't be. Okay, let's go ahead and do a sine curve, and this time the sine curve is going to have a change in the period. So let's graph y equals 2 minus 3 sine 2 theta plus pi. Okay, so just as a quick review, we always start with a new midline. I'm going to cheat and call this 2. So I don't have so many lines. I'm going to go up 3 to 5 and down 3 to -1. All right. The plus pi means that I start pi to the left. All right. So I'm going to start at -pi. The 2 here means 2 cycles in 2 pi. Shortcut, take 2 pi and divide by the c value, and that is the period of our transformed sinusoid. So if I start pi to the left and the period is only pi, that means I'm going to end at 0. Okay, so halfway between -pi and 0 is -pi over 2. Halfway between -pi over 2 and 0 is -pi over 4. And halfway between -pi and -pi over 2 is -3 pi over 2. All right, and then I'm going to go ahead and because it's the sine, I start in the middle. Because it's the opposite of the sine, I'm going to flip it. And so my nice sinusoid Should look like that. Okay, great. I'm going to leave you with one and ask you to work on this on your own, and then I'll get a volunteer to come on up to the board and show me this transform sinusoid. Okay, nice work. See you in class.